So proving log identities, we just want to use log properties to show that the left side equals the right side. So in this case here, when we take a look at this, we have base 3 log here, we have base 10 log here. So those don't match, so we have to somehow make them match. So I can use change of base to make this into base 10, or I can use change of base to make this into base 3. Here, I kind of see that we have a divide by log 3. So this actually is already kind of set up for change of base formula if we want. I'm going to do it slightly differently though. So I'm going to change the left side to base 10. Okay, so log base 10 of 3x squared over log base 10 of 3. So when I do that, I have the same base on both sides, or sorry, the same denominator. So then I can just split up the numerator using log properties. So I could just do log 3 plus the exponent comes on top out front and becomes log 2 log x, and this is all over log 3. So I can make the left side look like the right side. Here it kind of looks the same, except I have base A, base 10, base 10. This is base A, base A. Okay, so how am I going to do this? So I'm either going to change everything to base A or everything to base 10. So in this case, I did change it to base 10. Here I'm going to change everything to base A. Okay, so I'm going to use change of base formula. Now, well, I might as well I'm just going to do it the long way, and we're going to just change everything to base A like this. So negative 2 log base A of B, that's exactly what I want. But then I'm going to generate log base A of 10. Okay, I kind of don't want that in there, but hopefully this changes things. Log base A of A, which is 1, but then I have to do log base A of 10. Okay, minus 3 log base A of B over log base A of 10. Okay, so everything seems to match except for these divide by log base A of 10s. Well, I can actually get rid of those because every term is divided by log base A of 10. So I'm going to times the top here by log base A of 10 and the bottom here by log base A of 10. And that will cancel out all those denominators. And I haven't changed the fraction because I've multiplied by 1. So I end up with 2 log base A B. The log base A of 10 cancels out. Here log base A of A is equal to 1. Log base A of 10 cancels out. Here I'm left with log base 3 log base A of B, and log base A of 10 cancels out again. So left side equals right side. And there's infinite ways you can do this. But again, the idea is just practicing using log properties. We're not going to really use identities, solve identities in calculus, but we're going to use log identities a lot to manipulate expressions. And we need to make sure we really understand our log properties. So we are going to solve some log equations. So here we need to solve this log equation. And we can maybe use an identity here. Okay, so I'm going to put this times 2. This is actually 2 times log A of x. So I can rewrite this as log A x squared. Well, this is an identity. Exponent and log undo each other, and we're left with x squared. And then I can solve this as a quadratic equation. Okay, so this is factorable. So we're going to end up with x minus 2, x minus 1 equals 0, x is equal to 2, x is equal to 1. We have to be careful though, because we always have to check for extraneous solutions. So can these solutions be plugged back into the x here? Yeah, they both work. They both are good solutions. But we have to always check for extraneous solutions. Okay, so that's very important. We check for extraneous solutions. This one we're going to solve for x. To solve for x, we need to get rid of these embedded. We need to get rid of logs. There's only 2 ways to get rid of logs. we can use the definition of log to convert it to exponent, or if we have log equals log, we can drop logs. Here we do not have a log equal log, so the only option we have is to use the definition of log. Okay, so definition of log, I need to have the log equal the exponent, then I can apply the base exponent equals argument. That's 16 there. Once I've done that, I still have a log, and again I can't make it log equals log, so the only way to get rid of that log to solve for x is again apply the exponent. So the fourth root of 16 is going to be equal to 2. So I get 2 equals 2x, so x equals 1. And again, make sure we check for extraneous solutions. Yeah, if I put x equals 1 in here, that is okay. That does not break one of my domain restrictions. So there it is. I've solved those log equations. Okay, we have to make sure we check, and I'm going to make a note here. Make sure to check for extraneous solutions. Okay, so this is very important that we check, especially with logs, because logs often have extraneous solutions, and we have to make sure that we eliminate those extraneous solutions when those show up.